Equipment profiling is most likely the most powerful feature of the iManifold application, and I really want to make sure you understand this feature to get the full benefit out of not only profiling the system, but using the troubleshooting that's incorporated into the application. In order to access profiling, what you do is sweep to the right to open up the main menu and select Equipment Profiling. Now, under Equipment Profiling, you're going to see a whole list of equipment profiles. Your list will differ from mine. Mine has some that I've custom profiled. So you can see here I have a beer cooler in here and a TU102, which is one of our training units. But these are all profiles that I made, and right now they're called quick profiles because I have them saved and selected so that if I want to use them again, I can. Now I'm going to close the profiling for just a minute, and just for ease of understanding, I'm going to put in some user inputs. So I went down, opened up the user input menu, and I'm going to select R410A system just because it's pretty common and most people know how to work that one. So as soon as I profiled the system, you can see it came up, and I have my suction line, liquid line, discharge line, and outdoor air temperatures. Now I can scroll left or right, so I'm going to scroll to the left, and when I scroll I get my tons of cooling, BTUs, kilowatts, and EER. Scroll again, I have supplier, dry bulb and wet bulb, and return air, wet bulb, and dry bulb. And then scroll again and I'm back to the suction line temperatures. These are all user inputs that came in off the demo data. These could also be user inputs that you put in, or this data can be coming wirelessly from the probes or from the wired probes, either one. Now that we have demo data in, here's where profiling comes into play. If we select equipment profiling, and I tell this now, and my first profile here is a 13 to 16 SEER 410A TXV system, what that does is it actually readjusted the scales for the superheat and the subcooling, and it put indicators on showing where the pressure should be for the high and the low pressures. Now if I scroll to the left here, I'm going to scroll to the right one more time, and this loops around so you can get to it either way. You'll see that now I have TSP, target suction pressure, TSH, target superheat, target subcooling, and target high pressure showing, and that target symbol in the center is indicating these are what the targets are. So my 118 is exactly lined up, and that's a 118 pound target, and I'm 118.0. On my high pressure though, you can see my target high pressure is 342. I'm actually at 350, but I'm showing just above the center indicator at the top. However, I'm not outside of the tolerance zone. This is plus or minus 3 degrees of saturation temperature, so it's within the target zone. Also, my target superheat is in the center. My target subcooling is in the center, so that superheat and subcooling are fine at 10 target and 10.8 actual, 16 target and 16.3 actual. And my discharge line temperature is around 170 degrees, so it's also in the center of the target. This is a perfectly operating system, and this is what profiling does. It shows us where the pressures should be, where the superheat and the subcooling should be, based upon the load conditions. So what we're looking at is our evaporator driving conditions and our outdoor air driving conditions that drive the pressures, and then our target superheat and subcooling for the system.